Morning, guys. Yeah, cool. So we're gonna start off where we left last time. I'll put the timer on, and then we'll do the register while you guys are doing this. So I think we started this, but yeah, let's say 8 minutes to start with today, just to get you recapped on what we were doing. No, my hotkeys are broken. That's annoying. All right, there you go. So 8 minutes there, and let's do this register. So, can you still hear me? Yeah, good. All right, so we've got Kezia, we've got Samuel, we've got Joseph, and Sam, Anna, Frank, Dan, and Regan. If anybody else is there, please comment when you hear that. That's the only people I can see at the moment. Yeah, Carrie, ticked you up on the list as well. Yeah, that looks good to me, guys. Let's give it a go then. So, show h must be this. We need to do separation of variables. So I'm going to get all the t's on one side, all the h's on the other side. So on the left-hand side, let's say it's 40 over h dh equals, and that's going to be cos 0.25t dt. We integrate both those sides. So we're going to get 40 ln h equals sine 0.25t. And we need to times that by 1 over 0.25 and plus c. We're told at the start of the ride it's 5 meters up, so h equals 5 when t is 0. Sorry, Zach, I'll swipe you in. So if I get rid of this, put it all on one side. Actually, maybe I can zoom out a bit now. So h is, what did I say it was? H is 5 when t is 0. So we get 40 then 5 equals 1 over 0.25 sine 0.25t plus c. Well, t is 0, so all this term disappears. Sine of 0 is 0. We get c equals 40 ln 5. Cool. Right, so we just need to put it all together and rearrange it to do the show that part of the question. So we're going to get 40 ln h is 1 over 0.25 sine 0.25 plus 40 ln 5. Now, if you guys put your 40 on the other side, your c is going to be different, but it will still simplify to the same thing. So yeah, I'm going to collect all of my I've got 0.75 there. Huh? Okay, yeah, that's 0.25 then. Cool. Right, so to do this, I need to collect all my ln terms together. So I'm going to get those on the left-hand side. So we get 40 ln h minus 40 ln 5 equals 1 over, so 0.25 is a quarter, 1 over a quarter is going to be 4. So we get 4 sine 0.25t. Okay, so we can divide both sides by 40 to get 4 over 40, or 0.1. So ln h, take ln 5 is 0.1 sine 0.25t. Divide those, ln h over 5 is 0.1 sine of t. E both sides, or take the exponent of each side, gives us h over 5 is e to the 0.1 sine 0.25t. And then times it by 5, and we get to the thing that we wanted to show. So that's the first bit. Second bit, find the maximum height of the passenger above the ground. So we need to solve this differential. So maximum point is when dh by dt is 0. So we can then solve this and say cos 0.25t equals 0. Well, cos equals 0. What are we talking about here? I think we want radians because we've got a very small angle there. I use e to c equals a. It becomes 5. No, I don't think it would. You've blagged too many constants there, Sam. If you're going to do stuff like that, it's fine, unless you're trying to do a show that, because then you need to find all those values. So you've got like e to the 0. What have you got, like 5 times whatever e to the 0.1 is to the power sign. Yeah, you probably lose a mark there. In a normal kind of question, it'd be fine, but in a show that question, you would get away with it. So we're trying to solve when cos is 0. We're doing it in radians, so it's going to be those two values there. Wait, what am I doing? This is stupid. I'm doing more. What am I doing? It's a 1 mark question. We don't need to do all that. Let's just look at our height equation. So what's the maximum sine can be? Well, sine can go from 1 to -1, so its maximum sine is 1. E to the 0.1, well, yeah, sine is going to be maximum of 1, therefore e to the power is going to be e to the 0.1. So e to the power is 1.11. Times that by 5, and we get 5.53, I suppose. That's your max height, which Hannah gave us and Sam gave us. So yeah, correct there. Last bit, the passenger reaches the max height for the second time t seconds after the start. So the first time passenger reaches the max height, yeah, we're not going to draw h. That would be impossible. So we're going to draw the differential. So we want to try and find these 2 times here. And we want to try and find this one specifically in terms of t. So that angle is going to be, if that's pi, this is going to be 3 pi over 2. So if I set my angle 0.25t equals 3 pi over 2, and solve that, we're going to get 3 pi over 2 divided by 0.25. Gives me t is 6 pi, and 6 pi is 18.85 seconds. Yeah. Which, right, you guys got 31.4, which is right. What have I done wrong? Because I remember getting that yesterday. Um, 5 over 2 pi. Yeah, okay. I can see. We want to put 5.53. There? I don't know, I should put it the other way around. That work, but why isn't this one working? So we said h is 0. dh by dt is 0, so Definitely that point, which is 3 over 2 pi. Five over 2 pi. Yeah, I'm not sure why it's not working that way round. I'll have a look at that later. But for now, yeah, the other one then. Divide both sides by 5. 5.53 divided by 5. Learn both sides. To get 0.1. So 0.10075 is 0.19. 0.25. Ah, yes, we just want the maximum of that. Yeah, we said the maximum was when that was 1. Yeah, we can skip all that. We'll get the same thing. So yeah, sine is 1 at that point, and then the next time will be at that point, which, as Sam said, is 5 over 2 pi. Cool. So 0.25 d, and yeah, divide by that. Yeah, I'm just wondering why I didn't work with my maximum from the differential. Yeah, you get t as 10 pi is 31.41. Oh, I know why I've done this. Sorry. All right, so explain why my idea didn't work. Let's draw cos again. I've been an idiot. So, I said the maximum is when the gradient is 0, and I straight away said the second time the gradient is 0 is there. See if you guys can work out what's wrong with this, because I have now, and I'd like to see what you guys think. So, you guys solved it by putting in the bit we just did, basically, which was quite clever. I kind of decided to use the gradient equation. So here's a cos graph. I said the maximum of cos, or the maximum of our equation, because the gradient is cos, I said those were the two maximums, and that I said this was the second maximum. Why is that wrong? So have a quick think, see if you guys can comment, why did I use the wrong, why is that not the right angle to use? So you 30 seconds, just have a quick think about that. See if you can comment your answers. Why should I not have used that that route or that angle? 30 seconds starting from now. Cool. I think, yeah, Dan got it. Gradient increasing here. Yeah. Okay. Reason is, if I draw a cos, if I draw a sine over the top of this, there's a maximum. Oh, there's a minimum. There's a maximum. So the second maximum is actually the point where we come down to 0 again. So we wanted this point. I found a minimum point. We actually wanted the second maximum. So in my head, I went second turning point. No, first turning point max, second turning point minimum, third turning point maximum again. So yeah, good one there. Okay, what we got next? 4 questions left. I would like to try and finish this past paper today, but we'll see what happens. I think it's doable. Okay, so we got binomial expansion. Should be okay. What's that? 6, 9, 10. 10 marks on this one. Cool. If you guys would like to start. My hotkeys aren't working. It's really annoying. Okay, yeah, Casper, yeah, I'll sign you in now then. Cool. And you got some answers? Good, nice. So Samuel, Kezia, Anna, Regan. Nice, good job, guys. All right, let's go through this one. So to expand this, we need to expand the top and the bottom separately. So we're going to get 1 plus 4x to the half times 1 minus x to the minus a half. And we're only expanding up to the x squared term, so we can kind of skip quite a lot of this. So we're going to get 1 plus a half times 4x plus a half minus a half times 4x squared over 2 factorial for the first one. Second one is going to be 1 plus a half times minus x, but it should be minus half there, plus minus a half minus 3 over 2 times minus x squared over 2. So let's work out what both these things are, times them together, and then we should be done. So we get 1 plus 2x, and we're going to use a calculator for this, so we get half times a half times 16, all divided by 2. So we get 2. So overall going to be a minus. We get minus 2x squared there. So that's my expansion of that one. Right, the other one, if I get rid of this now as well, is going to be 1 plus x over 2. And then we got minus 0.5 times minus 1.5 divided by 2. So we get 3/8 x squared. Right, so all I need to do is times these two things together up to the x squared term. So I can ignore any terms that are going to be more than x squared. So 1 times 1 gives us, let's write these out next to each other and make it a bit easier, won't it? So let's put all that in brackets. Cool. So timesing that by 1 plus 2x minus 2 squared. So 1 times 1 gives us 1. That's that one. 1 times 2x gives us 2x. 1 times minus 2x squared gives us minus 2x squared. Okay, and now let's do the next one. X over 2 times 1 is plus x over 2. X over 2 times 2x is going to be x squared, so plus x squared. And the next term is going to be x cubed, so we're not going to do it. And the last one we need to do is this one, so plus 3 over 8 x squared. So overall, we're going to get a 1. We've got 2x plus x over 2, so that's 2 plus a half, so that's going to be plus 5 over 2x. We've got minus 2 plus 3/8. Don't know if this is going to be right, actually. I feel like I've done something wrong. Minus 2 plus 3 over 8. Ah, we've done something wrong. Oh, no, we're right. I've just forgotten an x squared. Minus 2x squared plus x squared is minus x squared plus 3/8 is going to be minus 5 over 8. X squared, good. So there's our answer to part A. Okay, now we're trying to use an approximation to root 6. So why shouldn't we use x as a half? Well, the expansion is only valid for, because we had 4x up there, I mean 4x less than 1, therefore x less than 1/4. This is only valid for less than a quarter. A half is more than that, so it's not valid for a half. Okay, last bit. Substitute x is 11 in to obtain approximation to root 6. So we're going to put 1 over 11th into both sides of this equation. I'm going to move this down so I get some more space. So we're going to put 1 over 11 into the left-hand side to get 1 plus 4 over 11 over 1 minus 1 over 11, 4 on the bottom, equals 1 plus 5 over 2 times 1 over 11 minus 5 over 8 times 1 over 11 squared. All right, so to do this, we need to get the left-hand side of this to equal root 6. So let's work out what we've got. 1 plus 4 elevenths is going to be 15 elevenths. 1 minus an 11th is going to be 10 elevenths. And if we divide those, 15 over 11 divided by 10 over 11 gives us 3 over 2. We get root 3 over 2. Still not quite root 6, but we're getting closer. So if I split this up and say it's root 3 over root 2, I could then say root 3 over root 2 and just write it at the top, because all we've done is mess around with the left-hand side. So all this stuff is going to equal root 3 over root 2. Okay. Right, there's a few ways you could do this. I'm trying to think what the most obvious way is. You could try and rationalize the denominator. That could work quite well. I'm not, though. I'm going to times both sides by root 2. So I'm going to basically turn it into an approximation for root 3. So root 3 would equal root 2 times the expansion. Still not quite root 6. What do I need to times root 3 by to get root 6, though? Root 2. So if I times both sides by root 2, root 3 times root 2 is root 6. Root 2 times root 2 is 2. And we got all the stuff. So if I do that, we get a pretty decent approximation of root 6. 1 plus 2.5 lots of 1 over 11 minus 5/8 of 1 over 11 squared. Sums that by 2, and I get root 6 equals 2.444. Let me just check that's right, roughly. Hereabouts, yeah. Cool, everybody okay with that? If you just put 1 over 11 to the left-hand side calculator. Oh, does it? Oh, I just wasted a load of time. Okay, cool, yeah, you can do that. That's completely fine. Yeah, I just like avoiding the calculator where I possibly can. But yeah, that's absolutely fine, Sam. Okay, next question. What are we up to? That was 11, so question 12 next. And we've got 45 minutes. Yeah, I think we'll finish this today. So we've got 10 marker, value of a car. It's a modeling question. So I'll give you guys 10 minutes to do that. Okay. Interestingly, my my Google Chrome has crashed, so I think the stream's still going. I can see you guys all commenting, but only on my phone. So yeah, technology is amazing, isn't it? Okay, what have we got? So Sam's done part A. That looks good. Part A. Part A too. Yeah, that looks good, Kezia. Part B looks good. Yeah, some really nice answers there. I think everyone that's commented is correct. So going through this one, find P to 4 decimal places. We need to put in these two values. So 32,000 equals A P to the power. T is years after 2001. So this one's going to be 4. And the other one, 50,000 equals A P to the 2012. So that's going to be 11. Right, now I can divide these to solve them. So 50,000 divided by 32,000 gives me 1.5625. A divided by A is going to cancel. And P to the 11 divided by P to the 4 is going to give us P to the 7. Then we're going to do the power 1.56. Just checking this is all right. Yeah, looks fine to me. Yeah, so we got P to the 7. If we do that to the power the power 1/7, we get 1.065. What was it wanted to? 4 decimal places. 1, 2, 3, 8. There you go. So that is P. So the A is approximately 24,800. So we're going to put that back into either equation. So 32,000 equals A times 1.0658 to the power 4. So do that to the power 4. Then do 32,000 divided by your answer. And we get A is 24796.8, which is approximately 24,800. Okay, interpret the value of A. So A would be our initial value. So if you put in T as 0, you get the value as A. The A is the, well, let's not use A, let's use 24,796, or let's use what they did in the question. 24,800 is the value on January, Jan 1st, 2001. Cool. The value P. P is the what to word this right? Should we go for amount of ratio or rate of change? It's playing the role of the gradient. Well, let's see. What was P? Look through your answers. What have you guys said? What did we get? Is this so P? So 1.0658 is the factor that the value increases by each year. So in other words, it's the gradient. But yeah. Okay, last bit, using the model, find the year where it first exceeds 100,000. So we need our value equation to be greater than 100,000. So we're on 2,4,800 times 1.0658 to the power t to be greater than 100 grand. So 100,000 divided by 2,4,800 gives me 4.0323 less than 1.068 power. That's the power t. We're going to log both sides. And use the power rule there. So I've used the brought the power t down. We're going to divide both sides. So we get t needs to be greater than log of 4.0323 divided by log 1.0658. Which gives us 21.88 years. So this was all recorded in Jan 2001. So 2001 plus 21.8 years is 2022.8. So it's during the 2022. So 2022 is the year during which the value exceeds 100,000. Cool. I'm just going to check the comments. I think everyone should be right with that. Cool. Half hour left. Let's see if we can finish it. Question 13 next of all. There's this little question here. So 7 marks. That should be doable in 7 minutes. Timer there. See how you get on. Okay. Nice. Yeah, good method there, Kezia. Cool. So yeah, substitution is the easiest way. You can also do this via by parts, which isn't much harder. If we think there's time, I'll go through both, but you are getting a bit tight. So to do it via substitution, u equals x plus 2. du by dx is 1 x. Limits then, u equals 2 plus 2 equals 4. U equals 2. The integral becomes 2 to 4. We also need x equals, you get 2x, which is 2 lots of u take 2, times root that, which is now u. So if we expand all this, we're going to get 2u times u to the half, which is going to be u to the 3 over 2, minus 4 half du. Do the integral, so that's going to go u to the 5 over 2. Divide by that will give me 4/5 out the front. The other one, u to the half, is going to go to u to the 3 over 2. Times that will give us 8 over 3. There, 2 and 4. So put the limits in. 4 goes in. Root 4 is 2. 2 to the 5 is 32. So 32 times 4 gives me 128. 5. Put 4 in. Root 4 to get 2. 2 cubed is 8. 8 times 8 is 64. That's our first limit. Take away second limit. We got 2 to the power 5 over 2. Gives me 4 root 2. Times by 4 gives me 16 root 2 over 5. Put 2 into the other one. 2 to the 1.5, which is 2 root 2 times 8 is 16 root 2 over. So we get those two. We can now just subtract those. So 128 over 5. Take away 64 over 3. Means 64 over 15. And the second one, 16 root 2 over 5. It's basically 16 over 5. Take 16. 3 lots of root 2, which is plus 32 over root 2. Take out a factor of 32 over 15, and we get to the answer we needed. Cool. So if you want to do it by parts, I don't think we have time, but real quick, I'll show you the basics of it. By parts, u will be the first bit, dv will be the second bit. U dash is 2, v would be, well, if dv is x plus 2 to the half, power goes up, x plus 2 to the 3 over 2, divide by that, you get 2/3 there. Put it all into the by parts equation and simplify, and you should get the same second to last line. All right, last question, 15 minutes to do it. So it's 10 marks worth of parametric equation. So can you guys give this a try? 10 minutes on the clock, and hopefully we can get through it in 5 minutes at the very end, and then we've done this paper. So 10 minutes now. Cool. Cool. All right, 5 minutes. Let's try and get through this. 5 minutes is going to be tight. Let's just check the comments, see how you guys did. Yeah, Sam, you can send me your workings. That's fine. I'm guessing that's for the last question. Yeah, both of you can if you want. Send it via Teams. Okay. Show all points satisfy this. So we need to find a Cartesian, and we're going to do that using the cos double angle formula. So I'm going to say y is 4 plus 2, 1 minus 2 sine squared t. Going to rearrange the x1 to get sine t. So x take 3 over 2 sine t. We're going to put that in. So y equals 4, 2, 1 minus 2 take 3 over 2 squared. Expand all that. Get y equals 4, 2 minus 4 lots x minus 3 squared 4. Get y equals 6 x minus 3 squared. So that's the first bit done. Then it wants us to sketch this curve. So it's basically a quadratic moved to the right by 3 and then moved up by 6 and reflected. So quadratic moved to the right by 3, reflected 6. Get rid of everything else. 3. There's my quadratic. But we have a t restriction. So we're not going to get the whole of the quadratic. So we need to find what the domain is. So t is between 0 and 2 pi. If I sketch x, x is a sine graph that's been stretched up to 2 minus 2. And then it's been moved up 3. So the top point goes to 5. The bottom point goes up to 1. Midpoint's going to be 3. Get rid of the curve again. R quadratic. Sorry, R sine. Well, like that. That's what we've got. So, and t is between 0 and 2 pi. So there's 0 and 2 pi would be to that point there. We need to find what x values are allowed. Well, x maximum is going to be 5. Minimum is going to be 1. So my maximum on this one's going to be 5. My minimum is going to be 1. Because it's quadratic, it's going to be symmetrical. So I can find out what y value relates to those two. So put 5 into the y equation as x. Get y equals 6 take 5 minus 3 squared. 5 minus 3 squared is 2. 2 squared is 4. 6 take 4 gives me a y value of 2. So that is what my graph should like. That is what my graph should look like. 1, 5, 3, 2, 6. And that's all we can do for our sketch. Okay, explain briefly why it doesn't include all the points. Well, it's because of the domain. 0 to t to 2 pi, restricts. Okay, how long have I been doing? I don't have any time. I'm going to go through this real quick, guys. So this other line intersects at 2 distinct points. So, shall we just? Nope. Let's just do this tomorrow because I don't want to rush it. It's 5 marks. The D here. Friday. Cool. All right, that was a bit hectic at the end, but you guys can always rewatch it if you need to. So, yeah. keep working through your assignments. Next week we will be looking at I think a bit more integration. I would like to do the area between a curve and a line and the area between two curves. Email me if there's any other topics that you want me to go over. Otherwise I'll just keep picking things and we'll just keep working through topics. Okie dokie. Yeah, that's it for today. Cheers guys. Have a nice well, I'll see you tomorrow, won't I? See you tomorrow. Morning, guys. Yeah, how are we doing? Could you all comment your names? A few of you have already, but let's get this register done. Cool. Right, who've we got? Okay, so Sam, Kezia, Anna, Regan, Frank, Dan, Samuel. Anybody else? Still missing quite a few of you. If anybody else is here that can't comment, please send me a message on Teams or email me. Cool. Right, let's get started then. So we're starting where we left off yesterday. So I believe we were just about to go through part C of this question. Did you guys all have enough time to do this bit, or do you want 5 minutes now to try and finish off part C? Yeah, so yes, I do, Dan. Yeah, don't worry. Yeah, do you guys want more time to do part C, or do you want me to just go through it straight away? Because I'm not sure how you guys did for time yesterday. I can't remember if we were. Give me a comment. I'll clear all the stuff off here anyway. I might keep a sketch, but a little bit smaller. But that's not it. Joseph here. Yeah, cool. I'll take you off. Cool, yeah, I'm going to give you guys a bit more time to try this. Zach, yeah, I'll take you off as well. If you guys, so 5 minutes, guys, see if you can finish off part C. We'll see how that goes. Starting from now. Yeah, that's fine, Sam. Try it now. See how you got on with it. It's 5 minutes. It's quite tight. You got to kind of think about how to do this one. Yeah, we'll go through it in 4 minutes, like I said. is quite true. I'm going to draw. Mike's on my head. Thank you. Yeah, so we're going to use y equals minus x plus k. Let's see if I can sort out what's going on with this light. There we go. That's better, isn't it? Cool. All right. Yeah, so we're going to think about a sketch. So for it to meet it in two places, if I draw it on here, it's going to be a line like this, basically. We can move it up and down. That's what k is. K is where it's going to be crossing the x-axis. And we want to find which values of k make it cross the line not once but twice. So for it to cross the line, actually, let's go back. The lowest point where this can cross it twice, if you imagine at that point there, it only crosses once. Here it only crosses once. It finally gets it twice at that point. So that's the point where it goes through 5, 2. So we can find the smallest k value, and then we're going to try and find the upper k value in order to find the range, if you like, of k between. I suppose those 2 points, if you guys can see that, that's quite a bad sketch, but try and find the k values between those two. Let's move myself up there. Between here, not here, between here and here, we want to try and find these k values. Imagine them on the y-axis there. So the lowest value is going to be where it goes through this point here, which is 5, 2. So we're going to put that in and find that point. Then we're going to use the discriminant to try and find this point in order to find the range of k values. So let's put 5, 2 into the equation. So we're going to get y equals 2 equals minus 5 plus k. So k equals 7. So that tells me that overall k must be greater or equal to 7. If it equals 7, it's going to go through that point, which means it crosses twice. If it's greater than 7, it's going to be a value bigger than it. What we need to do, though, is try and find the upper value for k. And the way we're going to do that is going to be with the discriminant. So we can find the value where k meets the line once. We can do less than that, and that will be the values. Sam, yeah, that's the upper value that you found there. That's what we're going to do now, but you haven't got the lower value. Cool, because obviously your value would be correct if we didn't have that, if we didn't have the bits chopped off because of our domain. But because the bits are chopped off, we've got the region has a lower bound as well. So I'm going to substitute these two together. So we're going to basically put y into that one. So I'm going to get minus x plus k equals 6. Take, and I think I'll expand this at this point. Minus x squared minus 6x plus 9. So minus x plus k is 6. Take x squared plus 6x. Take 9. Get it all on one side, so we're going to get minus x squared plus 7x minus 3 minus k. So that's my quadratic. So we need to do the discriminant on this. So b squared minus 4ac equals 0, because we want to try and find this line here where it touches once, and we're going to be less than that k value is going to go there. So putting it in, we get 49 minus 4 lots of minus 1 times minus 3 minus k, which will equal 0. So we're saying 49. We're going to get minus 12. And minus 4k equals 0. So 4k equals 37. So k is 37 over 4. So that's my upper bound. This equation, 37 over 4. And it's got to be a less than sign, and it's got to be a less than or equal to sign for the bit lower than 7. Yeah, everybody okay with that? It does say set notation, so we ought to give it in terms of that as well. So k dot dot curly bracket curly bracket. Cool. All right, that's the paper done. So what are we doing for the rest of the day? Well, I wanted to do some revision on integration. So really quickly, we're going to go over all the different types of integral. And then we're going to start looking at some mixed integration questions for today. Next week, we're going to do area between a line and a curve and a curve and a curve. And then maybe look at separation of variables and some of the harder calculus topics. If there are specific things you guys want me to go over, though, please let me know, and I'll plan lectures accordingly for those topics. All right, so I think I've got some of this lecture done already, so I'm just going to go have a look, see if I can find it. Maybe not. Might be in here somewhere. If this ever loads, there we go, cool. Maybe I'll start a new one. This one's quite laggy anyway. Cool, so integration. Okay, first thing is inspection, or recognition as we call it. So remember, there's 3 types that you've got to try and remember, or you've got to be able to spot and recognize. There's f dash x, e to the f of x. There's f dash x, f of x to the power n. And there's f dash x over f of x dx. So the key to spotting these is spotting 2 different parts in your 2 different functions that are either times together or divided, and one function is the derivative of the other. So some people call them function derivatives. In each case, you can see we've got f of x, the differential of f of x, f of x, the differential of f of x, f of x, the differential of f of x. So you got to spot that first of all. If you can spot that, the rest of the question can become pretty easy. So for the top one, we try e to the f of x. And what I mean by try is your answer will be of that form. You're just going to need to tweak the coefficients, maybe differentiate it and check, but it will be to do with tweaking coefficients. Now the reason why it's e to the f of x is if you imagine differentiating e to the fx, the f of x bit will turn into f dash of x, and the e to the fx bit will stay the same as e to the fx. So that's why that one's the case. The next one, we try f of x to the power n plus 1. And the reason we do that, the inside of this, if I put it in brackets, inside f of x will go to f dash x, which we got. The outside, the power is going to go up by 1. We're probably going to divide by the new power, maybe, but we're going to need to tweak that coefficient when we check. The last one, we try learn f of x. And you can see the inside of this, f of x will differentiate to v of dash x. Learn of something goes to 1 over the something. So those are the three you've got to be aware of. And you're going to see some today where it's a bit harder to tell which one of these two it actually is. Okay, so that's recognition. And that's kind of a part of the reverse chain rule topic. So reverse chain rule really is just like a standard integral where you've got to think a bit harder about what the coefficient is. So you've got your standard integrals, you've got sine, cos, e to the x, ln x. I'm not going to go through those because they're all in the form of the book anyway, and you should really know those by now. The next big topic is by parts. So we got u dv dx x. We rewrite this rewrite that as uv minus the integral v u dx. And the whole point of this is we go from a product of two things, one of which we don't want to integrate. So if you look through, u is here, u isn't integrated, then we differentiate u and write it here and integrate that. We're never actually integrating u. So it's also a method that lets you do an integral of two products, one of which you don't want to integrate, and the other of which we do integrate. So dv dx gets integrated here, and then it actually gets integrated again here as a product. So that leads to some choices for how we decide what to choose for u and what to choose for dv dx. So u, we use the acronym LATE. I do that very well. U, LATE. Remember, we got log first, algebra second, trig, and then exponentials. The reason trig and exponentials are at the bottom is because they normally integrate and differentiate to new trig or new exponential. So you're not actually simplifying anything. Whereas with algebra, if you integrate or if you differentiate algebra, each time you differentiate, the power gets knocked down until it becomes a number, and then it's not really affecting your integral anyway. And by differentiating a log, you're going to get 1 over x, and then 1 over x is going to help simplify your algebra a lot quicker as well. So that's the order with this one. And then really, if you get the order right, you do your differentials, do your integrals, put it all together. And if you know how to do the integral, nice and easy. So that's a quick explanation of by parts. The other big topic is substitution, which I know some of you really hate. So first thing with substitution is you want to choose a substitution that gets rid of the bit that looks difficult. So for example, if we had 2x root x take 3, the bit that makes it look difficult is the x take 3. So I would make u equal x take 3. And then we just need to do a few things. So once you've got your substitution, you need to find dx du or du dx. So du dx. Find the new limits if there are any. And then turn x's into... So u is x minus 3 in this case. We're going to get root. Du dx is 1, so I know that dx is du. Then all I need to do is change that 2x at the beginning. Well, we can rearrange this equation to say x equals u plus 3. We got two lots, u plus 3 times root u. And there's my changed substituted integral. Expand that, and it's a lot easier to integrate that than it is to integrate the thing in the beginning. So that's substitution. The last bit I want to talk about briefly is trig. So that's good. Yeah. So with trig, obviously the things you should just know: sine, cos, sec squared, cosec squared, tan squared, cot squared. Should be easy enough. Sine squared and cos squared, we use cos double angle. Obviously, tan squared and cot squared, I've not written them. I've written them at the bottom. Tan squared and tan squared and cot squared. You would use your 1 plus tan squared equals sec squared kind of equation. 1 plus tan, or 1 plus cot squared is cosec squared. So those would be for your tan and cot squared. If you've got a product of trig, it's either going to be the sine double angle if your angles are the same, or if your angles are different, you're going to use the sum product rule. If your angles are different, so those two. If it's a sine cubed or a cos cubed, write as sine times sine squared, or cos times cos squared. That's pretty much it for trig. It can be a bit harder, and you want to be able to spot things. Remember, the differential of sec is sec x tan x. So if you've got a product of sec and tan, you might start getting confused thinking it's difficult, but really sec tan is just the differential of sec, so you can just write equals sec. It's a standard integral, but it's one that people often forget. Okay, we're going to just jump in and try some integrals because I don't want to spend ages talking about the theory where half of you are already very happy with this from all the revision you've done. So I've got some mixed integrals. Some of them do get pretty tricky. Don't think we'll get through all of them today, but if not, we will finish them on Monday. Cool. All right, so we're going to start off with 8 of these on screen. And I'm going to give you guys 10 minutes to try and do these. There's some difficult ones. There's a couple of partial fractions in there. Shouldn't be too bad though. Be careful, question 3. Question 3 is one that you could easily slip up and make the wrong decision. But otherwise, they should be not too bad, these ones. So 10 minutes on the clock starting now. Yeah, sounds fine. We can do parametric integration and differentiation. That's all right. All right. Hopefully that was enough time. Let me know if it wasn't. If you guys want more time, I can give you another couple minutes. Just looking at it now, maybe 10 minutes was tight. I don't know. If you want a couple minutes, hit something now. I'll go through the first one. If you want some more time, we'll give you a break after that. So cos integrates to give sine. So I know my answer needs to be of the form sine 3x take 1. If we differentiate sine, we get cos, but the inside would differentiate to give us a 3. There is no 3 in the integral, so we need to put a third at the front. And now if we differentiate it, 3 will come outside, times by the third, which will cancel each other out, and then we'll get cos 3x take 1. Alright, no one's commented, so I'm going to assume you want me to go through it, so we'll just keep on going. Alright, e to the 1 minus x. Well, e to the x goes to e to the x, so my answers can be of the form e to the 1 minus x. If we differentiate that, though, we're going to get a minus out the front, which we don't want, so we need to introduce our own minus to cancel out the minus we would get. All these are going to be plus c. Yeah, there you go. Okay, next one. And this next one might look like it's f of x, f dash x over f of x. And you can kind of spot that is the differential of the thing there. But the bottom is squared, so it can't be this one. So what we need to do instead, bring the bottom bit, bring the denominator up to the top. So we're going to get 2x plus 1. We're going to get that to the minus 2. And then, those of you hopefully will have spotted that it's one of the function to a power times the derivative. So it's actually one of these ones. F dash x, fx to the n. That's what we're dealing with. So we're going to try n to the minus 1. So we're going to try x squared plus x minus 1 to the power minus 1. If we differentiate that, we're going to get the inside's going to go to 2x plus 1, which is what we wanted. But we're also going to get a minus 1 out the front, so I need to get rid of the minus by introducing my own minus. Cool. Question 4, cos 2x. Well, cos integrates to sine, so we're going to try sine 2x. This is very similar to the first one we did. But if we differentiate that, we get 2 out the front. We don't want the 2, so we need to put a half in front of our answer. So that's the first 4. Next one is partial fractions. Good. So we're going to get a over x minus 1 squared plus b over x minus 1 plus c over x plus 2 is whatever. Cross multiply to get a x minus 1 plus b x minus 1 x plus 2 plus c x minus 1 squared, all equals 4x take 1. So we're going to let x equal 1. And we get 4 take 1 is 3, equals, everything cancels apart from the last one. For c we get, no we don't. For b then we get 1 plus 2 is 3b, therefore b is 1. Let x equal minus 2, so we're going to get minus 8 minus 1 minus 9. I've left something out, haven't I? Yep, I've done something wrong. That should be minus 2. Plus 2 even. Cool. So put minus 2 in, and a and b are going to disappear, so we're left with c. So we're going to get equals c times by minus 2 take 1 is minus 3 squared, which is 9. So therefore c is negative 1. And to find a, I'm going to let x equal 0. So we get minus 1 equals 2a minus 2b plus c. So we know b and c, so minus 1 equals 2a. Take 2. Take 1. Let's add all that, so you get minus 3 on one side, add it to the other side, minus 3, minus 2. So we're going to get 2 is 2a, a is 1. So going back up to the top, a is 1, b is 1, c is minus 1. Cool. All right, then we're ready to integrate. Yep. Okay. So first term, to integrate that, we're gonna need to write it as x minus 1 to the minus 2. Then we can actually do our integral. So gonna go to the power minus 1, so we get x take 1 to the minus 1 with a minus in front. Then we're gonna get plus ln x take 1 and minus ln plus 2. And we ought to simplify these using log rules. So we're going to get minus 1 over x take 1 plus ln x minus 1 over plus 2. Like that. Okay. Question 9 then is a by parts question. So we're going to choose u as ln, dv dx is x cubed, and this one shouldn't be too bad. So du dx is 1 over x, v is x to the 4 over 4. Put it all together, so I'm going to get uv, x to the 4 over 4, ln x, minus v du dx, which is going to be x cubed over 4. Integrate that, we're going to get x to the 4 over 4 ln x minus x to the 4 16 plus c. All right, next one is let's get some water. Next one is okay, next one is again partial fractions. So tedious, but we can get through it. So factorize the denominator. So we get 5 over brackets 2x, x, what we're going to have minus 1 minus 3, I think. So that's going to be a over 2x minus 1 plus b over x take 3. Cross multiply, and we get 5 equals ax minus 3 plus b 2x take 1. Let x equal 3. X equals x. Let x equal 3 to start with. And we get 5 equals 2 times 3 is 6. Take 1 is 5b. Therefore, b is 1. Let x equal half. We get 5 is minus 2.5a. So a is minus 2. So 1 for b, minus 2 for a. That's what we're trying to integrate. So minus 2 over 2x minus 1 is going to go to minus ln 2x take 1. We left out the 2 there because when we differentiate this, the 2 will come out anyway. Then the last term is going to be plus ln x minus 3. We can use log rules to simplify this, so we get ln x take 3 over 2x take 1. Right, and the very last one is another recognition question. So, power differentiates to 2x plus 2, which is similar to that. So we're going to go for e to the x squared plus 2x. because it's one of those function derivative questions. If we differentiate that, we're going to get twice as much as we need. So we need to get half in our answer. Cool. All right, that was fast, but you guys can pause it and go back through it if you need to. And nobody said they needed more time anyway, so I assumed you all got it right. Let's do some more of these. So where did we get up to? 11 and 4. All right, so we're going to try 6 now. I do think these are slightly harder, so I'm still going to give you 10 minutes to do 6. So let's see how you do. Comment your answers, please, guys, and comment if you need any help or any tips. So 10 minutes starting from now. Cool. How was that for time, guys? Everyone managed to get through them okay? We'll start going through them. Cool. All right, so first one, integrate ln 2x. So we need to use by parts with u as ln x, or ln 2x, dv dx as 1. So du dx is going to be 2 over 2x, which is 1 over x, and v is going to be x. So put it all together, uv, x ln 2x, minus the integral of 1, which is x ln 2x, minus x plus c. Right, question 6 on this list then. This is very similar to the one we did earlier. So we're going to write this out as x times x squared minus 1 to the minus 3. And then we've got derivative times the function with a bit of a tweak. So we're going to try x squared take 1 to the minus 2. Now if we differentiate this, we're going to get 2x out the front times by minus 2, so we're going to get minus 4x out the front. We just want x out the front, so we need to divide it by minus, well, times it by minus a quarter. So that's your answer there. Next one's kind of a standard integral, so we got integral of 2x take 3 to the half. So the power is going to go up to x to the 2x take 3 to the 3 over 2. Now if you differentiate this, you get 2 out the front. You also get 3 over 2 out the front, so that would cancel that and give you a 3, so we need a third for our integral. Next one's quite interesting. So in question 12, you need to spot you've got f dash x over f of x. So if you think differentiate sine, you get cos, differentiate cos, you get sine. We've got those on the top. So we're going to try ln sine minus cos. If you differentiate that, you'd get cos minus sine, which isn't what we have. If we compare them, we've got the negative version of that. So we need to introduce a minus sign so that we get the right answer. So we need a minus sign out the front there. Okay, x squared sine 2x is by parts, and I think we're going to have to do by parts twice. Because we've got x squared, the first version of by parts will turn it into x, and the second version will turn it into a number. So du dx is 2x, and v is going to be minus a half cos 2x. So a little bit by parts there. Not by parts, a little bit of inverse chain rule there. So we're going to put it all together. Minus a half x squared cos 2x, so that's uv, minus the integral of v du dx, that's going to be minus, so plus x cos 2x. Okay, so yeah, I need to do by parts again, so u is x, dv by dx is cos 2x, u dash is 1, v is half sine 2x. So do the integral, write it all out, minus a half x squared cos x plus uv, so that's x over 2 sine 2x, minus the integral v du dx, so minus a half sine 2x. So we integrate that, and the final answer, minus a half x squared cos x, sorry, cos 2x, plus x over 2 sine 2x. Sine 2x is going to integrate, or minus sine 2x will integrate to give us positive cos 2x, so we're going to get quarter cos 2x. So that's your answer at the bottom there. Right, last one is sine cubed 2x. So sine cubed 2x. The way we do this is we write it as sine squared 2x times by sine 2x. We turn the sine squared into cos, so we're going to say that's integral of 1 minus cos squared 2x times by sine 2x. Expand it to get integral of sine 2x minus sine 2x cos squared 2x. Cool, right, now, first bit, sine 2x easy, we can just integrate that. So that's going to go to minus a half cos 2x. And this bit, hopefully you guys can spot, is a function derivative. So we're going to try cos cubed. If we differentiate cos cubed, we'd get 2 out the front, we'd get 3 out the front. The cos would turn into minus sine squared 2x. So if you look, minus sine 2x cos squared 2x. Look, we've got mostly that. We've just got this extra 6, so we need to divide by 6. So plus 1/6 cos cubed 2x. Now if we just check that through quickly just to make sure, we're going to get 6 times 1 over 6 times minus sine 2x cos squared 2x. So the 6's all cancel, minus is there. Yep, so that's it. Cool, if you've got any questions about those guys, please ask. But the trick to all these really is being confident with the reverse chain rule. If you can do that and remember some methods, these shouldn't be too difficult. Okay, we've got 20 minutes left today. I would like to get a couple more of these done. So we've got 4 on this slide. Let's see if you guys can get those done. They're all kind of similar, so you can see we've got, this is really to draw your attention to the different ways of integrating these fractions. So yeah, I'll give you 10 minutes to do it. That'll bring you to 1/2 and then we've got 15 minutes basically to go through them. Cool, so 10 minutes starting now.
Right, let's go through these. So, first one, we're going to change it to integral of 3x take 8 to the half dx. Power's going to go up. We get 3x take 8, 3 over 2. Divided by 3 over 2, so we're going to have 2/3. There'd also be a 3 come out. So if we differentiate this, we get 3 come out the front, we get that bit come down to get rid of that. So we need to have a 9 on the bottom there. And you can kind of see that the 3 over 2 will come down, the 3 will come out as well, so we have 9 over 2. We need to get rid of 9 over 2, so we need 2/9 there. So we need to put in our limits, which are 24 and 8. So we get 2/9 of 3 times, let's do it on the calculator, 2/9 of square root of 64 to the 3 over 2 minus 2/9 of 16 to the 3 over 2. So we're going to get 2/9 of 8 cubed minus 2/9 of 4 cubed. Which gives us 896 over 9. Sorry, which one were we talking about? So it starts as minus a half on the bottom. Oh yeah, sorry, I've been stupid there. Yeah, oh damn it. All right, let's redo that because that's definitely wrong. Well spotted there, Sam. So the power is going to go up to positive a half. So we need to times by 2, divide by 3, so we actually get 2/3. We get that. Okay, that's a lot easy to work out. So 2/3 of, what was it, 3 times 24 take 8? 64. Minus 2/3 of 16 to the half. So 2/3 of 8 minus 2/3 of 4. Gives me 8 over 3 is my answer. Cool. So that is the first one. Second one is going to be log. No, it's not. Second one, we've got to use some long division on this one. Or I suppose you could probably get away with substitution as well. I'm going to use long division though. So 9x divided by 3x, we get 3. Subtract those, we get 6x plus 24. So we get 3 plus... Wait, that's not right. That should be a 9. That should be 0. So 3 plus 24 over 3x take 8. That's what we're actually trying to integrate. So that's going to give me 3x plus ln 3x take 8. And we want an 8 out the front as well. So I think we should be getting that for the second one. We need to put the limits in again though. So we get 3 lots of 24 plus 8 lots of ln 3 times 24, take 8. Take away 3 lots of 8 plus 8 ln 73 ln of 3 lots of 8 take. Cool, so 3 times 24, 72, plus 8 ln 64, minus 24, take away 8 ln 16. So we get 48. We need to use log rules for this bit, so let's take out a factor of 8, so plus 8 ln 64 over 16, which is ln 4. So I believe we get that. All right, 2 left to do. Okay, next one. Integral 1 over 3 take 8. And this one is going to be nice and easy. This is just ln, so ln 3x take 8, and we need to put a third out the front as well. And that's going to go for 24. 8 there, so we get a third ln. I think I'd remember these now. 64, isn't it? Third ln 64 minus a third ln 16, which gives us a third ln 4. Right, and the last one. It looks like another. Oh, is it actually? This looks to me like a repeated root partial fraction, I think, for this one. So, let's say it's a over 3x take 8 plus b over 3x minus 8 all squared. And I feel like there should be an easy way of doing this. But I'm going to just do it this way. This will definitely work. There probably is a quicker way though. So we get a 3x take 8 plus b just plus b equals 9x. Let x equal 8 thirds. So we're going to get b equals 9 lots of 8 thirds. Which is 24. And then let x equal 0. You get 0 equals minus 8a plus 24. So 8a is 24, so therefore a equals 3. So a was 3, b was 24. That's what we're trying to integrate. So first one, we're going to get ln 3x take 8. That's it. Second one, we're going to turn that into 24, 3x take 8 to the minus 2. So we're going to get 3x take 8 minus 3. If we differentiate that, we get 3 down the front. We'd get minus 3 down the front as well, so we do need a minus. That would give us 9 on the front. We want to get to 24, so we're going to get 8/3. 3x minus 8 to the minus 3. Cool. Anyone got any questions about any of these? If you do, please post a comment. You can always message me in Teams if you like as well. So yeah, I'll finish these off next week. There are a few more. I think I've got 1 page left of these mixed integrals, and then we'll start looking at area integrals. And Sam, you want us to do parametrics. If you remind me on Monday, I'll make sure that happens. Cool. All right, have a good weekend, guys, and I'll see you next week. Cheers.